as the science of generating, producing, and managing materials or nanoscale structures. It is a new trend in technological growth in the 21st century. The results in innovative characteristics can be used in a variety of technological applications. It acts as a gateway to scientific advances that have a substantial impact on global industry development. The National Nanotechnology Center, or Nanotech, has the mission to support and promote the nanotechnology potential in the country, as well as enhance people's competitiveness and quality of life in accordance with the country's development goals, which is described in the current National Economic and Social Development Plan. Nanotech aims to advance research and development in order to introduce technology to the manufacturing sector to support commercialization. We also drive research and development to benefit the social sector. Finally, we aim to strengthen academics and scientific manpower in order to support the country, economic and social development in all aspects and build a strong cooperation network with domestic and international partners. At the moment, there are 16 nanotech research teams organized under 5 research groups. Nano Encapsulation Research Group. The research group specialized in designing and synthesizing necessary encapsulation systems, as well as employing nano-encapsulated technology to increase the precision delivery of active substances. We designed the environmentally friendly procedures to undertake quality control for our synthesis and extraction technology of our key chemicals. We also perform bioactivity tests for the creation of nanocosmetics, medicines, and pharmaceutical formulations to expand our platform into commercialization products in the health and medical industries. Responsive Materials and Nanosensor Research Group. The research group specialized in material design and synthesis, including structural modifications on the nanoscale to produce highly sensitive sensors for the applications in health, agriculture, and food. We also developed the micro and nanostructured electronics to meet the requirements for medical applications. Our research covers the diagnosis, treatment, and follow-up of critical illness to meet the current medical practice standards and to improve Thailand's healthcare-based technologies. Nanocatalyst and Molecular Simulation Research Group. The research group specialized in advanced catalyst technology and nanomaterials, as well as the technology based on molecular computing and artificial intelligence for converting biomass into high-value compounds. Our research and development are employed in the energy and petrochemical industries, including the domestic biorefinery industries, energy storage technologies, and clean energy technologies that will help reduce greenhouse gas emissions in order to make the most efficient and long-term use of Thailand's domestic resources. Nanohybrids and Coating Research Group. The research group specialized in the development of microparticle-sized materials nanomaterials, and polymers to generate functional fibers, nanotextiles, and surface modifications of materials that have unique features and high efficiency. We also develop a nano coating technology for a wide range of surfaces for textile, alternative energy, agricultural, and environmental technologies. Our research also deals with problems in water and air resources. Advanced Nano Characterization and Safety Research Group. The research group specializes in nanoscale analysis to investigate nanomaterial characteristics such as size, shapes, surfaces, and physics-chemical compositions. Moreover, we also perform the toxicology studies using cells and tissues as well as zebrafish model to ensure the product safety in human and environment. Our group has high-precision analytical techniques and widely recognized test models to investigate the product's biological activities and efficacies certified, and has experiences in creating engineering prototypes which could fulfill the needs of a number of industries, including textiles, plastics, food, pharmaceuticals, and cosmetics. Nano Agricultural Chemistry and Processing Research Team. The research team specializes in the development of food technology and agricultural product processing using nanotechnology and biotechnology for generating food products for mankind and animals, as well as solving challenges in the agricultural and livestock sectors. Our team aims to improve food and agricultural productions in industrial sectors of Thailand. Since 2003, we have been committed to build a knowledge on nanotechnology through research and development with our full potentials and expertise to create the impact of Thailand's economy and society. We believe that science, technology, and innovation are the engines that propel the economy forward, increase the industrial sector's competitiveness, and improve the quality of life of the people in the country. Then the people will be ready to deal with any changes that leads to a better future.
To make Thailand a great country through science and technology, the Wittaya Sirimati Institute of Science and Technology, or VISTEC, whose name graciously bestowed by Her Royal Highness Princess Mahajakri Sirintorn, means Science Institution for Exceptional Talents. Located in Wangchan Valley, Rayong Province, VISTEC focus on the change of Thailand educational landscape, especially in development of science and technology. Our challenging goal is to be ranked among the top 50 universities in the world by the year 2035. To be one of the top research universities in 20 years, we need to have outstanding faculties, state-of-the-art facilities, and frontier research. VISTEC will exploit creative ideas in education management for developing the skills of talented individuals in science and technology through 6 distinction qualities. 1. Industrial hospital. 2. Full-time postdoctoral system. 3. Tenure track system. 4. Curriculum design. 5. Small size, big advantage. 6. Frontier research. VisTech, our subjects focus on key technology for the future, which are energy and environment, advanced material, biotechnology, and digital. Thus, there are 4 schools at VisTech which are related to key technologies for the future. The School of Energy Science and Engineering, or ESE. At ESE, we focus on innovative battery technologies, advanced functional material, and industrial process for energy applications. The School of Molecular Science and Engineering, or MSE. The research at MSE covers the fields of advanced catalysts, nanomaterial, dye-sensitized solar cells, and polymer. School of Biomolecular Science and Engineering, or BSE. The school target is to be a technology leader in 3 areas: synthetic biology and metabolic engineering, biocatalysts and enzyme engineering, and biosensor and detection technology. The School of Information Science and Technology, or IST. The research focuses at IST include scalable data systems, artificial intelligence and machine learning, robotics, health analytics, computer vision, and natural language processing. VisTech is then founded Frontier Research Center in order to strengthen research in science and technology and to integrate and applied research for practical usage. Here, Frontier Research Center provides state-of-the-art research facilities or world-class instruments, public and private sector. Unlike anywhere else, in order to operate the machine, certified students are allowed to control and run their experiments by themselves, with the close supervision from expert scientists. Our journey began in 2013 with contribution of the pioneer founders and key donors. Following the roadmap, we have achieved multiple goals and are aiming towards being one of the top 50 universities in the world by 2035. We also have industrial funding, not only from PTT Group, but also from government and private sector. Here we pursued synergistic partnership with industry's global universities in certain important areas. These collaborations allow our faculty members, researchers, staff and students to work closely with real users on industry challenges and build up clusters of creative scientists and engineers to meet future challenges. Our faculty members and researchers made high quality and high impact researches possible in the field of advanced science and technology that are significantly included in the Nature Publishing Index, which is a global indicator, and other high quality international journals. Our university is shooting up the national ranking and ranked one of the top 3 for chemical science among Asian countries. Top 2 in all subjects, and being number 1 in Thailand for chemical science. Moreover, Nature Index Rising Star shows the top 30 academic institutions established as universities in 1988 or later, and VisTech is ranked 12th by the growth in fractional count. This success has been achieved largely without the advantage of time, as we believe that education is a major tool in improving our lives and in turn enhancing the country's human capital. VisTech aims to boost competitiveness and foster the best people in science and technology to ensure and guide sustainable development and increase prosperity to contribute to Thailand 4.0.
Good morning, distinguished guests, ladies and gentlemen. My name is Pichaya Patana Satayawong from Vitiya Sirimeti Institute of Science and Technology, or VisTech.
And my name is Gyanida Triratrakun from National Nanotechnology Center, or Nanotech.
We would like to welcome you all to the opening ceremony of the 8th International Nanotechnology Conference, or Nano Thailand 2023, which is held from the 29th of November to the 1st of December 2023. And for this year, Nano Thailand 2023 is co-hosted by Vittaya Sirimeti Institute of Science and Technology or VISTEC, National Nanotechnology Center or Nanotech, and the Nanotechnology Association of Thailand.
The theme of Nano Thailand 2023 is Nanotechnology for Sustainable World, and the goals of the conference are to apply nanoscience and nanotechnology for a better life and well-being, to create a platform for knowledge exchange to further advance technological areas, and to exhibit the latest innovations to the industries.
In Nano Thailand 2023, we have invited outstanding and renowned researchers to present their exciting advances in various areas.
Before we begin, please be informed about the safety procedure of the Sithani Hotel. In case of an emergency, please direct to the nearest emergency exit and walk through the hotel lobby to the assembly point at the parking lot. Next, in order to comply with the PDPA law, we would like to disclose that the Nano Thailand 2023 organizer may collect, use, or disclose photographs and video footage from this event.
And now I would like to invite Dr. Pawadi Angwattana, the Deputy Director of National Nanotechnology Center, to deliver the welcome speech on behalf of Dr. Wanni Chinsirikun, the Executive Director of the National Nanotechnology Center and the current President of the Nanotechnology Association of Thailand. Please welcome Dr. Pawadi.
So my name is Pawadi. I'm very honored that today, this morning, I will deliver welcome remarks from Dr. Wanni Chinsirikun, President of Nanotechnology Association of Thailand and the Executive Director of Nanotech. Dear Excellencies, distinguished guests, ladies and gentlemen, good morning. A very warm welcome to all present here. It gives me a great pleasure to welcome you to Nano Thailand 2023 in the theme of Nanotechnology for Sustainable World, which is co-organized by Nanotechnology Association of Thailand, Vittaya Sirimeti Institute of Science and Technology, VISTEC, and National Nanotechnology Center, Nanotech of NASDA. I am very honored that Professor Supachai Patumnakul, Deputy Permanent Secretary, Ministry of Higher Education, Science, Research and Innovation, as well as the Executive Chairman of Nanotech's Board of Directors, presides over this event as the Chairman of the opening ceremony. I also wish to express my sincere appreciation to Professor Susumu Kitagawa and Professor Kees Dekker for your time and contributions as the plenary speaker in this important event. Special thanks also go to all the keynote invited speakers and all participants. Please allow me to say a few words on behalf of the Nanotechnology Association of Thailand's committees. Nanotechnology Association of Thailand was established in 2010. Its major objective is to support and promote academic knowledge, R&D of nanoscience and nanotechnology, together with providing mechanisms in driving such knowledge or findings to applications with tangible benefits for industry and society. All activities geared towards enhancing the country's competitiveness and people well-being in sustainable manner. Nano Thailand is organized every 2 years by Nanotechnology Association of Thailand in collaboration with RNN, or Research Networks of Nanotechnology in Thailand. The first international conference, Nano Thailand 2008, was organized by Nanotech, or National Nanotechnology Center, followed by the other 6 conferences organized by เกษตรศาสตร์ University in 2010, Khon Kaen University in 2012, Mahidol University in 2014, and Suratnali University of Technology in 2016. Next, Chulalongkorn University in 2018, and latest one, King Mongkut University of Technology, Thonburi in 2021. And this time, Nano Thailand 2023 is again organized by Nanotech by having Vistech as the co-host. Vistech was very kind to open house their facilities for the conference participants to pay a visit yesterday. Visit also included EECI, or Eastern Economic Corridor of Innovation, managed and operated by NASDA, with key roles of National Research Center, including Nanotech on biorefinery and Thai herbs nanovation. For instance, position of EECI is to be the hub of innovation for translational research and development in Wangchan Valley, Rayong. This year, the conference theme reflects the integration nanotechnology with material science, biotechnology, engineering, and to address both fundamental nanotechnology opportunities and their practical application towards a sustainable world. This event is bringing together leading scientists, researchers, and innovators to exchange experiences and create an environment that will promote new ideas, enhance borderless collaboration opportunities, and finally, enhancing the nanotechnology capability for global sustainability. With regard to this event, to give you some specific and interesting figures, Nano Thailand this year, we have more than 350 participants from more than 25 countries, and a total of 278 presentations, including 196 oral presentations with 2 world-renowned plenary lectures, 97 keynote and invited speakers, and 82 poster presentations. Kindly note that the year 2023 also marks the 20th anniversary of Nanotech, and we are very honored to be able to include our participation in Nano Thailand 2023 as one of the celebration activities of Nanotech. Ladies and gentlemen, I would like to take this opportunity to express my sincere appreciation to the organizers for this special event. Thank you all speakers and participants for taking time off their busy schedules to join us. Thanks to our sponsor for valuable supports, and thanks to all behind the scenes with all kinds of supports and contributions that make this event possible and surely a very successful conference. On my final note, I sincerely hope that you will enjoy today and tomorrow's conference along with all networking opportunities. Well, apart from your fully dedication to many interesting technical sessions at this event, I do hope that you will also find some time to enjoy the beautiful beach and fascinating places here at the vibrant city of Pattaya. With that, a very warm welcome to everyone. Thank you very much.
Thank you, Dr. Pawadi. Next, may I invite Professor Vinit Prom-Arak, co-host of Nano Thailand 2023, to present the briefing of the conference. Please welcome Professor Vinit.
Dear the chairman of the opening ceremony and all delegates, this is the 8th Thailand International Nanotechnology Conference, or Nano Thailand 2023. The largest international nanotechnology conference and exhibition in Thailand. And Nano Thailand, this conference series have been organized biannually since 2008. And this Nano Thailand 2023 in the theme of nanotechnology for sustainable world. is co-organized by VISTEC, Nanotech, and Nanotechnology Association of Thailand. This year conference welcomed over 350 participants, a total of 278 presentations, including 196 oral presentations, and with 2 renowned plenary lectures, 97 keynote invited speakers, and 82 poster presentations. This scientific presentation will be cover various nanotechnology topics, including nano encapsulation, theory and simulation of nanosystem, nano safety and standard, nanomaterial and nanotechnology for electronic, optoelectronic devices and sensor, nanomedicine and nano for biotechnology, nanotechnology for energy storage and energy management, nanotechnology for environment and agricultural, nanotechnology for catalysis and industrial applications, nanotechnology for startup and industrial enterprises, nano characterization and instrumentation, and 3 special sessions on advanced nanostructured material for a global circular economy, symposium on bio-based chemical and fuel from lignocellulose, and the second Thailand symposium on nanopore technology. Again, this year, Nano Thailand 2023 cannot be successful without help and support from Nanotechnology Association of Thailand, VISTEC, Nanotech, and NASDA, and all the co-organizers and sponsors. The contribution from all members of the organizing committee and the scientific committee, as well as the advisory board, are gratefully acknowledged. Finally, I would like to thank all the distinguished guests, speakers, presenters for their kind and insightful contributions, and staff who dedicate their time and hard work for this conference. Thank you, the chairman of the opening ceremony, for making this event much more meaningful. And I wish all participants a pleasant and fruitful meeting in this conference. Thank you.
Thank you, Professor Vinit. And next, may I invite Professor Supachai Patumnagun, the Deputy Permanent Secretary of the Ministry of Higher Education, Science, Research and Innovation, and Chairman of Nanotech Advisory Board, to deliver the opening remarks. Please welcome Professor Supachai.
Sawadee krab. Distinguished guests, ladies and gentlemen, good morning. It is my pleasure and privilege to give the opening remarks for the Nano Thailand 2023, an international conference under the theme of nanotechnology for sustainable world. Talking about the sustainability, it is the ability to exist and develop without depleting our natural resources needed to live in the future. Science, technology, and innovation play the crucial roles on how to keep developing without consuming our existing resources to maintain those resources for the future of the world. Since 2015, the United Nations has adopted the Sustainable Development Goals to call for action in ending poverty, protecting the planet, and ensuring our people enjoy peace and prosperity. To achieve these 17 goals, our countries around the world need to work together and share their knowledge to accelerate the progress of sustainability. the one without more advancement in the particular field of science, technology, or innovation, could support the others that need the knowledge in the field for their development. Ladies and gentlemen, I am very pleased to say that as our country is progressing towards Thailand 4.0, a new value-based and sustainable economy for better living of our people, the government is supporting more spending on science and technology in order to obtain satisfactory justifications. Government shifts the attention to more impact and mission-oriented public research programs and looking for a more direct and larger scale involvement of researchers and their host institutions in fueling knowledge-based growth with sustainability perspectives. To support the sustainable world, Nano Thailand 2023 provides 10 various fields of advancement in nanotechnology with 3 specializations, including advanced nanostructured materials for a global circular economy, symposium on bio-based chemicals and fuel from lignocellulose 2023, the hub of knowledge. And the last one, the second Thailand Symposium on nanopore technology. Conferences such as this could provide a valuable opportunity for research scientists, industry specialists, and decision makers to share experiences. I am grateful to many experts who have come to share their knowledge this week. I am sure we will all have fruitful and rewarding exchanges in the next few days. Before I end my remarks, I would like to take this opportunity to thank the organizers of Nano Thailand 2023, the sponsors for your kind support, and thanks to those behind the scene contributors who helped making this event a successful one. Thank you very much. ขอบคุณมากครับ
Thank you very much, Professor Supachai. Please kindly remain on the stage. Next, may I invite Kun Paw Bunyarattapan, Vice President of Nanotechnology Association of Thailand on the stage, please. And next, may I invite Professor Jamrat Limtragoon, President Emeritus of VISTEC, to the stage, please. And last, I would like to invite Dr. Pawadi Angwattana on the stage for the ribbon cutting ceremony. Please wait for my cue on the count of 5 before commencing the ceremony. Five, 4, 3, 2, 1. Okay, please take a moment for the photographer to capture this beautiful opening ceremony. Thank you very much.
And now I would like to invite Professor Supachai to present a token of appreciation to our major sponsors for the conference. First, I would like to invite Kun Ratanachai Suthidechanai, the marketing representative of the Thailand Convention and Exhibition Bureau, or TCEP, on the stage, please.
Thank you.
And next, I'd like to invite Kun Pusak Hiranya Trakul, the Managing Director of Para Scientific, on the stage. Thank you very much, Professor Supachai. Please kindly remain on the stage. Now we come to the Nano Q Slogan Award from the Nano Q Slogan Contest for Sustainable Nanotechnology Development in Thailand project.
This project is initiated by Nanotechnology Association of Thailand, together with Nano Safety Network for Industry project, and receive financial support from the Council of Scientific and Technological Associations of Thailand, or COSTAT.
The aim of this award is to promote NanoQ certification from Nanotechnology Association of Thailand, as well as nano safety and standard to the industries and society for the sustainable development of nanotechnology in Thailand. Moreover, the winning slogan in this contest will be used in the campaign to promote NanoQ in Thailand, and all the three awardees will receive the token and the prize.
In this occasion, I would like to invite Professor Supachai Patumnakul to give the token to the winners. I would like to also invite Assistant Professor Dr. Thanakon Osotjan to give the prize, and Dr. Phawadi Angwattana to join the ceremony as the winners. Thank you.
And the second runner-up is Kun Sansern Pisuthipot, but unfortunately due to an urgent matter he cannot join us today, but he sends his representative on his behalf. Please welcome the second runner-up representative.
Next, please welcome the first runner-up to the stage. Please welcome Kun Thananan Thira Sathit-wong.
And the winner of this slogan award, please welcome Kun Rachawadi Dara Sawat. And the winning slogan is นาโนเทียมนาโนแท้นาโนแน่ๆต้องนาโนคิว
Okay. Now I would like to invite all the award winners to come to the front of the stage for a group photo.
May I also invite Major General Associate Professor Dr. Chainarong Cherchu, the President of COSTAT, that provide the financial support for this project, to join us on the stage for the group photos as well, please.
Thank you very much, everyone. And in the next session, we will have a photo session. For the first group, Professor Supachai and Dr. Pawadi, please remain on the stage. And may I invite Professor Jamrat and our two plenary speakers, Professor Susumu Kitagawa and Professor K. Stecker, on the stage, please.
Okay, please kindly remain on the stage first, please.
Everyone,
Please
please,
stay, Professor,
remain.
Professor Decker,
Professor,
Kitagawa-sensei, please remain.
remain on the stage.
We have 3 sets of photos. Yeah.
อาจารย์ด้วยค่ะ
And next, may I invite the Executive Committee of Nanotechnology Association of Thailand on the stage for the second photo session, please. So we have 3 sets of photos and then 1 more with all the participants.
Once you are on the stage, please kindly remain on the stage. Okay, the photographer. Okay, everyone don't move. Please stay where you are.
One more set.
One more session.
One more set. Yes.
Okay, thank you. Next, I would like to invite Nano Thailand 2023 Organizing Committee on the stage for the third photo session.
Okay, thank you very much, all the distinguished guests, for your participation. And now I'd like to invite everyone back to your seats, and we will have a final photo. So the photographers will get on the stage and then take the shot of the whole audience with us.
So everyone in the audience, please give your beautiful smile to our photographer on the stage. And wait for the cue. 1, 2, 3, smile. Keep smiling.
And next, we will now proceed to the first plenary lecture of Nano Thailand 2023 by Professor Susumu Kitagawa from the Institute for Integrated Cell Material Sciences, or ICIMS, Kyoto University, Japan. Professor Kitagawa obtained his PhD degree from Kyoto University. He is currently a distinguished professor at Kyoto University Institute for Advanced Science, or KUIAS, and the Institute for Integrated Cell Material Sciences at Kyoto University. He has received numerous prestigious awards in science and is a member or fellow of various distinguished academies and societies as well. Professor Kitagawa originated the science and technology of gas manipulation with porous coordination polymers, or PCPs, and metal organic frameworks, or MOFs. He predicted early on the softness of PCP and MOF crystals and demonstrated that their framework changes in response to external fields to express various functions such as storage, separation, and conversion. He named these materials soft porous crystals, or SPC, and pioneered their chemistry, which is now rapidly spreading to other porous materials. And his topic today is chemistry and application of soft porous crystals from metal organic frameworks, or MOFs, and porous coordination polymers, or PCPs. Please welcome Professor Kitagawa.
Thank you very much for very kind introduction. Good morning, Excellencies and distinguished guests and colleagues and friends. It's my honor to be here, and I'd like to express sincere thanks to the organizers and the people involved in Nano Thailand 2023. So let me start with this slide. Today, my talk about the chemistry and the application of porous materials it's kind of very structure-like the talk. So if you are not interested in the chemistry, in the organic molecules, so forget it. Just look at structure, okay? So, and to start, my talk contains the 3 parts. The first one, just look at the current world. The second, in my chemistry, how this chemistry started and expanded. And lastly, the just application, and in this case, so start in the part 1. In 19th century, humankind created the new technologies that consumes a lot of energies. That time, people used coal as energy resources. And as you know, in the 20th century, in the liquid petroleum was used. Still, we are using this. So, And what about 21st century? We think the gas substances are major resources. So in particular, in the ubiquitous gas substances are very important. But however, humankind is not in control of gases. So just look at the very small molecules. They are the gas states in the ambient conditions. Besides in this water, but the water still has, as you can feel, they are kind of humid. So in a sense, we can say the gas substances. So these gas substances are involved in the environment, natural resources, energy, even in the case of life. So very important. So this is the ideal, the image, and also the important things. So I think the air is invisible gold because air contains the carbon, oxygen, hydrogen, nitrogen elements. So by using elements, we can produce a lot of things, even in the case of living system. So the problem is, these are gas substances. We have to capture these gas substances and they concentrate and also they store these gas substances. And by using the renewable energy and the water, hydrogen, but this case is also hydrogen, so we can convert, we should convert the very useful materials, feedstock and fertilizers. So even if these materials are combusted, very sensitive, sorry. Yeah. And once again, these substances go into the air, so we can make this saturation. But this is very ideal stage right now. So in the Asia, the mountain hermit, it is said, mountain hermit live on haze. Haze contains the air, of course, air and water. So this is very, very ideal, but we should realize this one. Air gold, yellow. Okay. But there are the big issues because gas substances easily diffuse and we cannot see these gas substances, and in the certain gas substances have a short life and toxicity. So they're very, very difficult to handle. So in order to do this, we have to create new porous materials. And also, by using this, the separation, storage, conversion process, that the technologies are important. In particular, under mild conditions, that's important. So let's go to my chemistry. Just before talking about my chemistry, I'd like to say my motivation and thinking. So in 2400 years ago, Chan Tzu said, the usefulness of the useless. Can you understand this? So everyone knows the usefulness of the useful, but no one knows the usefulness of the useless. This is very important notion, okay? And so there are nothing useless, but if we think this is a kind of space for ions or molecules, that would be useful. So in nothing but we construct this kind of the framework, in particular in the accumulated framework having the small pores. That is the so-called porous materials. It's very useful. Okay? The space is very important. Just look at the imagination. This is the famous artist Escher. He drew this kind of framework in a two-dimensional face. Okay? So you see, this is the framework. Also, this is the framework, but the two-dimensional. So the question is how we can make this type of framework in a nanoscale. So the macro scale, you see this is in the Kyoto, and we have a very famous temple, and Kiyomizu Temple. This is a balcony of this temple, and this temple is constructed from 139 pillars of Zelkova. But in this construction, no pegs were used. But in the macro scale, it's easy to construct these kind of things. Not easy, but maybe easy. But nanoscale, what we can do? Just imagination. Use the components and just like this. But however, it takes a long, long time to get the whole framework. So this case, we use magnet. So question is, can we have this kind of magnet in the nanoscale? The answer is yes. We call the coordination bond. Coordination bond has a kind of glue between the metal ions in the organic molecules. So by using this tool, we can construct this kind of connector. Of course, this terminal end can connect it to the others. So we can get the very beautiful structure. This is we call in the metal complex. So you have the organic molecules and the metal ions. Just mix in the solution. So you can get this kind of regular framework in a minute. In the fastest case in a seconds. So the other case also. What kind of network you can see? This is the basket net, kagome style. Even on the surface of the crystals, we can construct this kind of network structure. Okay, so we call these compounds porous coordination polymers because this is constructed by using the coordination bond. So porous coordination polymer PCPs or metal organic frameworks, MOFs. Whatever terminology you can use, of course. So once again, you design the framework and so choose metal ions, organic ligands, and mix. That's it. For instance, in the case of diamond-like structure, and you can choose the straight ligand and the tetrahedral type ions, you can get this one. Conversely, you get the tetrahedral organic ligands and straight metal ions. Okay, so the other things is the honeycomb structure. So this is the scheme in straight and the tetrahedral metal ions, but we can block one side. So the three coordination type gives this kind of structure. Just I'll show you. This is the 1 micron crystals, very small. Okay, and you cannot see these crystals. And we can determine the crystal structure like this, okay? Here. So in this side, this cavity, in this side about 1 nanometer, okay? So that means in the 1 nanometer cavities exist on this side 1,000, this is 1,000, totally 1 million channels in just a tiny 1 micron crystals. So this is enough for our purposes, okay? So in the channels, the gas molecules are accommodated in this way. This is in the case of CO2. So why these small cavities are important? Just please look at this one. This is just a dice type, and you have 4 face, 4 panel. In the one panel has 1 square centimeter. So totally inner surface area is 4 square centimeter. If you have the 1 micron, 1 micron, and the channel structure like this, the cross section is like this, and so the total inner surface is 400 square centimeter. That's 100 times larger than this. But if you can make this kind of the channel systems, 0.8 times 0.8 square nanometer size. What about this? 2200 square meter. Very large inner surface area you can get. For instance, in the methane molecule has a 0.4 nanometer, so in the cavities, 4 methane molecule accommodated. So totally, the methane molecule, the 150 cubic centimeter methane molecule accommodated, but this case is 1 cubic centimeter, okay? Just like this, in Japan, we have this kind of hotel, okay? In a small area, small space, we can accommodate many people, okay? So in the reality, in the macro scale also it happens, okay? So this is inner surface area. This is basketball court is the zeolites. Zeolites has about the basketball court inner surface area. And activated carbon has 2,500 square meter per gram, just a half football field. But in the materials, in the researchers synthesizing a huge, big surface area materials in the 4,500 to 7,000. Very light materials. So can you imagine, just you have 1 gram, 1 spoon for these materials, you have the football field surface area. So the people said, this is constructed to the organic molecule. This must be unstable. But the certain materials showed very stable to the acid, the strong alkaline conditions, and the feed in the temperature around 550 degrees and the high humidity, very stable. So today, just I want to tell you about the expanding of this chemistry. This is the years, this is the expansion in the evolution of coordination polymers. So I want to tell you about the history about this. So I talked about this kind of framework, but as a synthesized structure like this, and the gas molecule accommodated, for instance, in organic solvent or water or something like that, if you remove these gas molecule, structure collapses. Sometimes happens like this. And also the people, they think about, this is the thinking of the people on about macro scale. Stone house stable, wooden house stable, but cardboard house maybe unstable. So they don't believe our materials is stable. So this is a challenge to get this kind of robust framework, okay? So I call this is the first generation, just a structure. The second generation is just a zeolite-like the porous structure, okay? So we succeeded in getting this type of functionality, and we synthesizing this is metal ion, nickel, cobalt, and this kind of ligands. We can get this entangled group structure. By removing gas molecules, we can carry out gas sorption many times. This has larger capacities than 0S13X. And also the Omayagi in the synthesizing the zinc type of framework and carried out sorption and evaluate the porous structure. So thanks to this development, this chemistry quickly expand in the last 20 years. So these are the functionality using this type of materials. Let me tell you about storage. So the audience, remember, just I showed you this high surface area like this. This is the model, okay, structure. But we synthesize this structure using copper 2+ and hexafluorosilicate and Ho4 prime by pyridine. So Ho4 prime pyridine kappa shows this kind of layers are linked in this ligand. Okay, so this has exactly the 0.8 times 0.8 square nanometer. So that means we can synthesize this type of framework like this. So, and you can expect the functionality of this the framework, because this case is a flat panel, but the reality is organic molecules. There is near distance interaction. Okay, this is attractive interaction. If you have the 4 panels, this interaction is stronger than this. Okay, that's very important. So thanks to these properties, for instance, this is just a methane sorption for the various type of materials. This is the borderline for the real gas vehicle systems, and this is increased more and more. So these materials have a high capacity to store the gas substances, and almost 10 years ago, already this is the Noh-Sei-san group. Calculate the computational approach to find the high capacity methane sorption materials. Just screening is the 137,000 moles was screened. So, but we are very much interested in the very dangerous gas substances. That is acetylene. Even in the case of this kind of cylinder, the explosion is very, very big. So very, very dangerous. So we try to store these acetylene. And this is the reality in the copper, and this ligand gives a layer. Layers are linked in this way, pillar layer structure. And then by applied pressure, the gas molecule accommodated like this. This has a high selectivity, the acetylene, in comparison with CO2, okay? So just this is a crystal structure and the channel direction like this, the cross section here. So the gas molecules accommodated in very, very beautifully, regularly arranged using the double hydrogen bond. So what is interesting is the concentration and in the density in the case, in the compression limit case is 0.2 megapascal. The density is 0.002 gram, but this case is 0.44 gram. 200 times larger than compression limit, but still stable. So in the gas phase, you can apply the pressure only for 2 bar. Abrupt explosion occurs because the acetylene is very reactive. But if you use this polar structure, and the acetylene molecules are safely stored in this way. Okay, let's go to the separation. This is a bit old data, but this is energy consumption of industry in Japan, and this is whole industry, okay, and consumes the energy. This is 100%. So among this, and the chemical industry consumes 34%. For this consumption, the distillation or certain kind of the separation process, the energy about 40% used. So totally, 12% of the total energy for separation processes used for separation. So can you believe this? And also in this commentary in the David Shaw showed even in the world, about 10 to 50%, the similar consumption for just separation. So separation is very important. Just look at the CO2. There are several situations about the CO2 mixture, and this is biogas contain the 50% CO2%, and syngas 30%, flue gas 15%, and so the most diluted case is air. The CO2 is 400 ppm. So that means this is concentration. This is the CO2 adsorption and energetics. We need more energy. Okay. So in this conference, the Professor George Shimizu from Calgary, he synthesized very interesting compounds like this, and this adsorbs this, CO2, and this is the absorption profile. This is the humidity, and this is the adsorbed amount. So the CO2 adsorbed even in the presence of the water, humid. So this is very useful for the separation. So this is a bit old data. Maybe George has the new one, but the startups create these materials for the flue gas for the cement industry. And in this case, the device is very important. So the new type of devices are important for separation, but they can create this kind of devices to separate CO2 in this way. So at the beginning, I told you about the air is invisible gold. So it is possible to direct capture, okay? Directly capture the air, in particular CO2, in the low concentration CO2. So once again, the CO2 concentration is 400 ppm, very difficult case. So this is a little bit old idea, and the old idea is to use amine. Amine can react with CO2, even in the low concentration CO2, to give a carbamate, or in the presence of the water, the bicarbonate, like this. So this bond is a strong bond. That's the reason why even the low concentration CO2, the materials can capture that. Okay. The problem is that in these materials after the certain processes and are a bit unstable, and also the strong interaction. And yeah, that is here about the heat of absorption is 70 kJ per mole, more than 70 kJ per mole. And sometimes the degradation happens. So just comparison. I'd like to say the previous one is chemisorption, chemical bond formation, chemisorption. But another one is physisorption. Physisorption shows no direct chemical bond with CO2. So this type is kind of interesting because in here and we can reproduce the CO2 after absorption of CO2. So this process may be important, but they're still under investigation. For instance, and certain idea is in the cavities put the amine, just like amine absorption, and but the energy is 80 to 100 kJ per mole, very large. But in the case of his absorption system, 47 kJ or 54 kJ per mole, very small. For instance, this is shift 6 in a certain type of the crystal structure, and so in this absorption profile in this pressure region of the CO2 show just the air concentration of CO2, okay, in the CO2. So there's still the high absorption, okay. So instead of introducing special strong chemical binding sites, physisorption with a structure that with a gas molecule physisorption, okay. So for instance, in this system, in the 400 ppm concentrated CO2, this absorbs the 0.05 liter per kilogram. This is 2 liter per kilogram. This is 9.2 liter per kilogram. So increasing more and more. So, and this is still under investigation. What is maybe this kind of the startups, the Climeworks, they set up just kind of the direct capture of CO2 like that. Okay, this is still under investigation and under development, but this is good news to directly capture CO2 from the air. Okay. So another thing is this is very fantastic in the experiments. Our institute colleague, Professor Satoshi Horike, and he's also the group on-site lab leader in the BISTEC. He's doing very interesting experiment. For instance, he used these amine compounds. So they just introduce air. So the concentration CO2 is 400 ppm. But this gives this kind of ligand to give more structure. Directly, this reaction is very easy. Direct to capture CO2 and to give framework compounds. So, yeah, this kind of the experiment, another type of the direct capture of CO2. Okay, so in this case, in about 25 degrees Celsius, and the 1 gram solids absorb the 0.7 gram CO2. Okay, so let's see the another ubiquitous gas in the air. That is water. So very recently, the researchers in the morph chemistry are interested in the direct capture of water from the air, and this is just distribution in the pure water area where easily the people get the pure water. But please look at this. This area is very hard to get the water. Okay, very, very hard. But Japan is very happy. But we have to contribute very much to this kind of the direct capture of water. Okay, and so just look at this distribution of the surface of the water, the pure water. I mean, of course the river and ice, glacier, snow, a lot of the water in this form. But if you look at the atmospheric environment, 0.04%. This looks very small, but the totally very large. Okay, so this is the idea, and the Omayagi. Just I introduced Omayagi's the results. Then this is the water absorption. Right now, the more than 40,000 more PCP materials are known. So there are different types of the water absorption. Very low pressure absorption and the certain pressure region, abrupt absorption like that. So they choose the special one and set up the direct capture of water from air. So they use the MOF 1 kilogram in 27 degree, 32% humidity. In a day, they can get 1.3 liter water. And this is the desert condition, and 10% the humidity. And even so, the 0.7 to 1.0 liter per day they can get. So the materials has a certain potential to direct capture of the moisture in the air. Okay. So let's move on to my main topic. I hope you enjoyed this kind of functionality of these materials. So this is the second generation type, 2G materials. So it is enough? What else works great? I think third generation should be here. So this is the development to discover and develop the third generation compound. So in the long time ago, I predicted the dynamic framework as a third generation compound. This structure framework changed depending on the gas molecule or external stimulus, like this. For instance, you can imagine, this toy is very famous toy, but component does not change, just angle change. You can see this size change very quickly. So in the early 2000s, and there are several this type of materials that were synthesized. This is layer dislocation type. This is hinge. Okay, pillar has a hinge like this. This is expandable case. This is also expandable case. And this is interpenetrated structure. Mutual dislocation gives a kind of flexibility. So in a certain pressure, this abrupt gate opening occurs in this case, okay? And so decrease the pressure, the change, the shrinkage occurs, okay? So what is interesting is this is our work. We observe the sorption profile. This sorption profile gives a sigmoidal curve like this. At room temperature, these gas substances, CO2, methane, O2, nitrogen, are supercritical conditions. That means even if you apply the very high pressure, you cannot get liquefied materials. So even so, we can recognize these gas substances in the expandable case and also the interpenetrated case. So the FX Kudat, and he calculated the energy, okay, thermodynamic energy with the open form and the closed form. The energy difference is 4 to 5 kilojoule per mole, very small. So that means this phenomena is cooperative phenomena. So I define this material again in third generation compound and rename this is soft porous crystals. But the audience just very suspicious about this because this moves like this, very fragile, okay, useless. Okay, I'll show you. This is example. This is interpenetrated case. We synthesize this type of materials for a lot. Okay, so we carried out gas sorption in the mixture of methane CO2. Okay, so in the case, this is a pellet we made, and so this has a selectivity for the CO2, very very good selectivity, and we carried out this PSA processes for many times. The guess is the CO2 is 500 ppm of moisture and room temperature. We carried out this 600,000 times PSA process. Still, our soft PCP is stable. Okay, so this is exactly the equivalent to the 7 years use. Okay, sorption, desorption, sorption, desorption, 600,000 times. And this is before and after the state of the pellet. So in a certain materials, it is stable. Okay, so this is a kind of paradigm shift. Then all the people believe that porous materials should be very static, robust, rigid. But our case is a kind of flexibility in global dynamics and showing this kind of hysteretic sorption. Okay, so after that, many people synthesizing this type of materials. So recently we published a review articles including most of the compounds. So if you are interested in this system, just look at this, please. And what is interesting in after that, many papers published. So the people use different type of terminologies. Okay, soft porous coordination polymers, flexible metal organic frameworks, crystal sponge, and so on and so forth. But we think the soft porous crystals, okay, include everything. Okay, because the soft porous crystal means even for the molecular solid crystal included. Okay, so this is a new concept because this is the protein or something like that, and this very soft materials, and this is the zeolite and rigid one. In between the MOF and PCP soft porous crystals located. So this is a concept in encompass porous materials. Okay, let me show the development of the gas science and technology. To store gas substances, the sorption profile is very important. In the case of zeolite, or like this, okay, or the second generation type, the sorption like this, and also soft porous crystals in the total, the saturated capacities are almost similar. Okay, but if you look at the desorption, okay, gas recovery process, in the soft porous crystals show the very good working capacity in the certain pressure. This case is ultimately to zero pressure is very important. So this is our work in the acetylene sorption, the previous slides I showed you. And after that, the people are synthesizing the very nice compounds. So this capacity increases more and more. But problem is, most of this capacity show this is a saturated capacity. So that means if you decrease the pressure along to this line, so the working capacity is very, very small. We need to have this kind of sigmoidal curve, okay? So right now we are standing from the discovery of SPC phenomena to the control of their functioning, okay? So let's apply for the storage of acetylene. Acetylene is very dangerous gas. We cannot apply the over 2 bar, okay? So, and also the safe storage and high discharge and working capacity is important. So we have chosen again this interpenetrated crystal compounds, and this is the strategy. In the deformation energy is a negative effect, but the aftercase adsorption, this is a positive effect. So totally compensate the deformation. Okay, so just short the introduction, and we introduce the substituent in the ligand system. And if introduce amino group, the repulsion is small. So that means they get moved to the lower pressure region. In the case of NO2 and higher pressure region. So the mixture gives a certain optimum conditions. So finally, we obtain this type of acetylene sorption profile. The 1 bar to 1.5 bar, we obtain the very nice sorption capacity. And so this work has a high usable sorption capacity right now. So the third generation compound is very useful. And so right now, you can see this kind of the acetylene cylinder. This contains the acetone to dissolve acetylene. But our system is a pure acetylene. So directly use the pure acetylene in this way. So further progress, I'd like to say. So you are familiar now about global dynamics, total crystal change. But if you see this case, and the local dynamics are also useful because this is constructed from organic molecule, okay? So this is imagination like this. The total framework is rigid, but the rotation occurs like that. So more than 15 years ago, we synthesized this type of layer type structure, and the pillar ligand rotate. So we estimate this rotation energy in this barrier is 7.7 kJ per mole. But we can change more and more this different type of systems. And so, we should apply to the very hard and difficult task. So that is H2O, the separation of the isotopos. Okay, so this is very important, and also the gas substances. So our idea is this one. So the big cavities are linked by the narrow channels. In the channels, we put this kind of mobile part, okay? So this is the butterfly mobile part. This is the dragonfly type, okay? Let's tell you about this one. Yeah, butterfly type here. This flipping the energy is about 12 kJ per mole, very small. So usually the gas sorption like this is the isobar, okay, constant pressure, the decrease the temperature. This is adsorbed amount like this. But this case is different because this fluttering motion depending on the temperature. The high temperature is like this. Very fast motion gives a smooth diffusion. So they adsorb like this, and middle temperature and the sorption and like this. And low temperature, the gate freezes, so this sorption does not occur. Okay. So please look at this. This is the molecular size and temperature, boiling point. So if the properties are very close to each other, for instance, argon and O2, so it's very difficult to separate. Okay, acetylene CO2 like that. So this case, we applied our compounds. This is just absorption in the case of O2, and this is the green one is argon. So if we look at this region, very high selectivity we can obtain. So let's move on to the application of the heavy water separation. Heavy water is very important, for instance, for the nuclear reactor, medical care, and the chemists are very familiar with this D2O, and even in the space development research. Problem is, in natural water contains very tiny amount of the deuterium. It's 0.04 or something percentage, and so this parameters, boiling point and freezing point and bond energy are very close to each other, chemically very close to each other, and so once you mix the H2O and D2O, the HDO produced. So the natural water contains only HDO. So it's very difficult to separate. So this is 100 years puzzle. In the 100 years ago, almost, and the D2O was discovered. And just after that, the Lewis produced the D2O. And after that, in the industrially produced D2O, just a separation. And this is the electrolysis, and this is distillation. And currently, the sophisticated the system, but the huge the plant is operating. So please look at this as separation factor. If separation factor is 1, that means no separation, impossible. So this is 1.05, this is 1.02, this is 1.2. So that means very, very difficult to separate. We have to apply more energy to get D2O. So this means in the fundamental science, we have to have new mechanism. We have to discover new mechanism. So we chose this ligand. Just motion is dragonfly. Okay, so we synthesize this framework. The 2 types of substituent are used, and this is the DBPA and IDB. Both show the similar structure, but the little bit different of this type of fluttering motion. So this is result. Okay, this is the kinetic absorption. This is the time we introduce the D2O and H2O, and just check the adsorbed amount. So that means the kind of the rate of the diffusion. So please look at this one. Red one is D2O, black H2O. There's a big difference. That means we can recognize these isotopes. But in the case of zeolite, exactly the same, activated carbon, exactly the same, ZIF7, it's a famous morph materials, and other morph materials, sorry. And what is interesting in this one? I showed you this whole the separation of this is a butterfly type system. Butterfly system does not work. Only dragonfly type works. Very subtle issue. But good news to separate this type of system using the kinetic factor. So this is very stable before after this option. And this material is very stable about water. So this is separation factor. Our materials show the 4 to 200, the easy to carry out room temperature. Other case is high temperature or very low temperature. Separation factor is around 2 or something like that. So there's a big difference. Okay. So third generation materials are very useful. We can challenge the very, very difficult issue. So this is the total of the chemistry of soft porous crystal, and we can modify the energy landscape and phase transition, static absorption, and dynamic the cooperativity, and so on and so forth. This is the outcome by using this, and of course the sensing and gas absorption and the catalysis. I have no time to show today in the catalysis also, and proton conduction and so on and so forth. So exceptional functionalities which conventional porous material cannot reach. So we are now studying 3G. So usually after my talk, people ask the question, what is 4G? So sorry, today you cannot ask me. I just first answer these questions. Okay, but anyway, in the 3G is this summarize the all aspect in the coming soon in the next year from the Royal Society of Chemistry. Okay, so 4G. 4G has been complicated, but the keyword is hierarchy, hybrid, anisotropy, asymmetry, defect disorder, HAD, WD. In particular, just I'd like to show the hybrid system. Hybrid means, of course, you can imagine that. For this accumulation, integration is important. Just a gate effect and highly accommodate and convert something, the array type or different type of quashare and something like that. So, and almost 15 years ago, I synthesized this kind of the PCP on PCP, morph on morph. After that, in the world, many people synthesize very fantastic integrated materials. So I have no time to introduce this, but this kind of materials are synthesized and not so difficult to synthesize. And at the beginning of this chemistry, the people believe that these materials should be insulator. We cannot get the conducting materials, but the last 10 years, researchers synthesized many compounds showing this is conductivity, electric conductivity here. So this is metallic conductivity. So these materials have also conductive properties. That's good news. And also the hybridization, the mixture, okay, of the morph and the other materials. This is the organic polymer with organic polymer. This is ionic liquids. This is morph on morph, PCB on PCB. This is metal with metal. This is the organic amines, and this is metal oxide here. And this is a covalent organic framework mixture. And the other case is the enzymes, DNA, dyes, and so graphene. So many combinations we can imagine and also realize. So one example, just I want to introduce you. This case is just conducting the case and just accumulate this case. This for the sensing materials. Okay. So this is the explosive, TNT, TNP, RDX, and something like that. So in the airport, you have a chance to have kind of detection, okay? So in this detection, FIDO is used, but this device works at the contact and non-real time. We need to have the non-contact and real-time detection. Best one is sniffer dog. This sensitivity is very good. Trillium fraction, PPT. The problem is they fatigue in a few hours. They need to have a rest. During that, we have to wait. It's not good. Of course, dog is very good, and also anyway. Okay, so we need to have the new type of the devices. Okay. So this is a kind of hybrid system, we think. In the aluminum oxide substrate, we grew this nanowire of titanium oxide. This is the semi-conducting system and for the detection. And so covered with both materials like this, before and after. Still we can get beautiful and the structure. So, and then this is the explosive materials. We detect these materials in the presence of UV light. And so this is the analytical curve here. So the lowest detection limit is around ppq. So please look at this. In the gas leakage, in the case is ppm, and volatile organic compound from the human body is PPB to PPT, but this explosives PPQ. So quite nice the detection. So this is thanks to the capacity of the nanorod type system has a big surface area for the metal oxide. And also the morph material has the selectivity and the capture of the low concentration materials. So this is the kind of the hybridization, and the interface is very a kind of the synergistic system. So we can develop more and more for the future, in particular in the human, the application to the human is very important in particular in the diagnosis of the various diseases. So only the few slides. Lastly, I'd like to introduce the practical application point. So at the beginning of the morph chemistry, this is the International Conference of Morph Materials, and the international conference was started at 2008, the Augsburg, Germany. After that, France, UK, Japan, US, and New Zealand, and unfortunately in the COVID-19, this case is web conference, and after that, the Germany and so on, so forth, and also, and the Euromorph conference is also organized like that. So last Euromorph conference in Granada, Spain, more than 500 people attended. And the main conference is maybe the 800 to 1,000 right now. Very active field. But this is a science. And on the other hand, around the 15 years ago, the startups were created. So many startups is coming to the present. Okay, so this is very important. This is scale-up commercialization. I am the academia person, so I think it's very important to our discovery to transfer to the society, but impossible to scale up. I just synthesizing crystals in the 500 milligram. But in the company, it's 500 kilogram, so impossible. So this kind of startups or industries are very important. Yeah, so, okay. So the double wheel drives are very important for this chemistry. Right now, it's very good conditions. And so the visible startups in the 39 right now, but the US people said the 100. And I cannot count the China. China is very dynamic and more. So this kind of startups is very important. And in Japan, the Atomis is our Kyoto University spinning out the startups. Already the 3 items are commercialized. So it's a very quick development right now. Okay, so the time's up. So summarize just I want to introduce this kind of the review article, commentary articles in the Nature Materials published in the 20 years. So for the special issue, we are invited to make a perspectives of the organic molecule-based porous materials that contains the most PCBs, coarse, host, and so on and so forth. Okay, so they are very important for the future. In particular, I think in particular in the gas substances are very important. So era of gas is now in this century. Era of gas, I think. So in these gas substances, In addition to gas substances, small anions are also very important. In the cavities are very useful for the transport, and also they activate or store energies in these gas substances. So that is not all, just a part of our chemistry. So I'd like to thank all my collaborators and the funding agencies, and so also today's audience. Thank you very much for your kind attention.
Thank you very much, Professor Kitagawa, for a highly insightful lecture. Now I would like to invite Professor George Shimizu from University of Calgary to present a token of appreciation to Professor Kitagawa. And if you would like to say something as well.
So thank you, Professor Kitagawa. I think for me, there are papers you can read and you can learn a new synthesis, you can learn a new technique. The best thing a paper can do for me is change your perspective and expand your vision. And so I've always found Professor Kitagawa's work to be extremely visionary. But as far as the usefulness of the useless, long ago I had the opportunity to have a one-on-one conversation with Professor Kitagawa, and he was explaining this philosophy. And it has many manifestations in Japanese culture. If you listen to traditional Japanese music, there are very large gaps of silence sometimes. And the silence is as important as the note. When you look at a Japanese flower arrangement, the ikebana, the empty space between the flowers is as important as the flowers. So as we see in a coordination polymer, the holes are actually very, very interesting, and especially when they flex. So please join me in thanking Professor Kitagawa. We have a gift.
Yes. Please go on the stage. Okay, so today, token of appreciation. This is a Puakani fabric, which is also known as volcanic soil dye fabric from the local wisdom of Jeronsuk sub-district, Buriram province.
And what is the special thing about this particular Puakani fabric, Kun Genida?
This Puakani fabric contains 3 nanotechnology coatings that provide antibacterial, soft touch, and water repellent properties. Okay, thank you.
And bear with me 1 second.
Okay, so this marks the end of the plenary talk. And next, there will be a refreshment break in front of this auditorium on the right-hand side and as well as on the left-hand side on the foyer until 10:45. There are also exhibition booths in the Napalai foyer. Please make a visit during the break to see more highlighted products from our sponsors, Nanotech and Vistech.
And the next parallel scientific sessions will begin at 10:45 in the Dusit rooms on the 5th floor. So the stairs up to the 5th floor, just outside next to the registration desk. And we'll have also one session in Napalai B next door. And please be noted that the room for session 6 has changed. Okay, the room for session 6 has changed from Dusit room number 5 to Dusit room number 11. And please check the program for the sessions you would like to attend. There are also poster sessions in the afternoon of both days.
Okay, lunch will be served at Dusit restaurant, which is in Napalai A on the right-hand side of this hall. There will also be a banquet for all participants tonight. The dinner will start at 6:30 here at Napalai B and C Grand Ballroom. Please come join us for delicious food and a chance for networking.
And the food prepared by the chef at the Sitani will have labels indicating its ingredients and allergens. All food ingredients that are not pork are certified as halal, and the food with no meat labels are vegetarian.
Before we end this morning session, on behalf of the Nano Thailand 2023 Organizing Committee, we would like to thank all the participants for joining the opening ceremony.
And we wish you a fruitful time at Nano Thailand 2023. Thank you very much.
Thank you.